Always a groovy way to start my day. Welcome in, everyone. My name is Jesse. It's so nice to have you back as we join in on another exciting Exploring by the Seat of Your Pants broadcast. For those who are new to us, we are all about bringing conservation, adventure, and science into classrooms around the world. Everything we do goes to our YouTube channel, so if you want to check out this program in 3 weeks, 3 years, 30 years, whatever, you can head right there and do just that. Lots of opportunity to share this and keep the learning going when we are done. Now, today's been particularly exciting. We just wrapped up with Dr. Tim Lamont in England talking about his Indonesian coral restoration work. Earlier today, we were live with Joe in Rio and then in Nicaragua releasing baby sea turtles into the ocean. So it's been a wild and crazy ride. I think we've gone through like 10 time zones. It's been a really good time. But I'm so excited because today we are bringing back one of my all-time favorite groups and one of my new favorite science communicators all in one go. We are live on the deck of the RV Falkor Too. So we've been joined with the Schmidt Ocean Institute for years now, featuring their amazing stories on their research vessel exploring the farthest reaches of the globe and the ocean, some of the most unexplored places on planet Earth, bringing you stories of the deep sea wildlife, the geology, the amazing science that goes on as we seek to understand this sort of misunderstood or ill-understood realm. Today, we are joined live off the coast of the Galapagos Islands by Veronica Harris. She is on an amazing website. She's on Instagram. She's one of the best science communicators in Canada and beyond. So I'm so thrilled to finally get the chance to meet her, bringing her on board this ship with the best backdrop of all time, really. So I'm going to stop talking. I'm going to turn it over to her to blow your mind with all the stuff they're doing on the ship on her expedition leg. And without further ado, welcome to the broadcast.
Thank you for having me, Jesse, and wow, what a welcome. I should have you introduce me everywhere. But as Jesse said, I'm Veronica Harris. I'm a PhD student at the University of Victoria, and I'm here on the research vessel Falkor Too, conducting my own science and also helping out with some of the other science that's happening here. So we are currently near the equator in Ecuadorian waters. We're actually in the Galapagos Marine Reserve. So we're very warm here. It's about 28 degrees air temperature, and the water is very warm as well, a lot different from my home of Canada. And I'm here to show you around the ship. So the first thing I would like to show you is the ROV. That's where we get all our samples from. It's a submersible that comes up from about 2,000 meters down. I'll just walk over to the ROV hangar and you can follow me. So this is a very large ship. It's much larger than any of the other research vessels I've ever been on. There are about 5 floors, and the back deck is the size of a football field. And the ROV hangar itself is 3 stories tall, so it's a massive operation that we're undergoing. This is our submersible Sebastian. We use it to collect our samples from the deep. On this expedition, we're doing ultrafine scale mapping and collecting of samples from hydrothermal vents, which are basically superheated geysers on the seafloor. So we collect water samples, we collect coral samples, we collect rock and sediment samples as well. And ROV Sebastian is equipped with everything that we need to get those samples. So we have our coral quivers, we have our Niskin bottles on the side. Actually, I'll just show you a little bit closer on the ROV. So these are our Niskin bottles. That's what we use to collect our water samples. They snap shut and basically take a snap picture of the water column at whatever depth we're at when we pull them shut. These are our coral quivers that we usually use to collect deep water corals, but I am currently using them to collect sulfide rocks because I'm working on the bacteria that live on these rocks. So I need them to stay very sterile and just in the state that they were at the bottom of the ocean. We also have push cores, which are basically long tubes that we push into the sediment to take a column of the sediment, and then we pull that out and put it back on the ROV. And that allows us to separate out different depths of sediment that we want to collect. And around the front, we have our bio boxes. So this is where the most exciting samples go, in my opinion, even though they're not my samples. We've been collecting things like skate eggs. We've been collecting giant tube worms from the deep sea, which I'll be able to show you a piece of them once we get into the wet labs. But we've also been collecting corals in these boxes here. So right now I'll show you what the wet labs look like. But that's all I have to say about ROV Sebastian. It can go down to about 4,000, 5,000 meters depth, so we're exploring very deep here, but normally the hydrothermal events that we go to are around 2,500 meters depth. Here we are. Hello. These are my friends, Brandon and Carlos. Brandon works with acoustics at hydrothermal vents, and this is his lander. Do you want to say a little bit about it?
Sure. So, okay, this is the deep acoustic lander. So it's got hydrophones on it. Oh, okay. Hello. Yes, my name is Brendan, and this is the deep acoustic lander. So it's got hydrophones on it, which are basically underwater microphones. So you can see 3 there in the vertical, and we have a pair horizontally too. And the reason we have so many is so that we can steer where we're looking with the hydrophones to try to determine the direction that the sound is coming from. And we'll use this to kind of investigate the soundscape at hydrothermal vents and also learn about the sounds that the vents produce to see if we can monitor how they change over time using the acoustics. Yeah.
And we'll come back to Carlos in a minute with the rocks, but first I'm going to show you the cold room. This is where I process my microbial samples, because everything that I do has to stay very cold. I actually store my samples at minus 80 degrees Celsius. And what that does is it freezes the DNA so that it doesn't degrade, and so that when I get back on land, I can extract that DNA from the rocks that I collect and the sediments and the water that I collect and have it be in good condition. But the really exciting thing that we have in here is this. And believe it or not, this actually came from a tube worm. So this is the sheath of a tube worm that lives at hydrothermal vents. It's called a giant tube worm, and you can see why. It's made out of chitin, so it's made out of the same thing that shells of crabs and some insects and shrimp are made out of. And they build these and then slide in and out of them, so you can see them poke their red gills out at the top at hydrothermal vents, then slide back in when ROV Sebastian gets too close and scares them. But this is just the shell, so the tube worm is no longer in here.
That is unbelievable. A professional detachment out
I will
the
now
window.
take you over to the rocks.
So cool. Oh.
Carlos, would you like to talk to us about rocks?
All right. Hey, everyone. So my name is Carlos, as I guess Maranki just said. And I've been working describing these rocks that we pull out from the bottom of the ocean. And, well, they look just like a bunch of dirt, but they're actually important because they help us understand how deposits that we mine on land form. And now a big question for environmental scientists is deep sea mining. And while understanding how these ecosystems work in terms of how rocks form, it's also important to assess the risk in mining these environments and what impact it could have on the biological communities that live around these hydrothermal vents. So that's basically it. Here you go. Thank you.
Thank you very much. So you're getting to hear from a lot of different scientists here. We have a varied amount of science going on this ship, which is why we have so many labs and so many different types of freezers. This is the wet labs. This is where biology happens. I'll just go in a little bit. Hello. These are our biologists, our resident biologists. So the tube worm sheaths that you saw in the cold room are actually part of Chong's samples. He studies giant tube worms. And they're also studying skate eggs. So if you want to get a little bit closer. Sorry, thank you. This is the shell of a skate egg. And Charisse, would you like to explain what it is?
Sure. Okay, great. Hello, everyone. So this is the case of an egg, And in the Galapagos here, we have these giant deep sea skates that we think are utilizing the hydrothermal vent areas as nursery grounds. So yesterday we captured amazing footage of a skate in its laying behavior. And then around the vent areas, we've been collecting these very large cases, and we're sampling these cases. Inside are the eggs, the embryos, and we're collecting genetics, and we're going to try study about adaptations and the population that lives in the Pacific to see if it's all one big population and how they benefit from hydrothermal vents. Yeah.
Thank you very much. Doing a little bit of maneuvering here with the headphones back and forth, but you're here for the ride and I love it. All right, here is the main lab. So a lot goes on in here. It's a lot of space. There are water samples that are filtered over there, and we do water chemistry. There are sediment cores that are processed over here by Maria and Hope from USGS, so the United States Geological Survey. This is the -80 freezer where I keep my genetic samples. And we also have our observers from the Galapagos Marine Park in here, observing the science that we're doing and joining in as well. Oh, okay. Perfect. So that's all I have for the labs. What I'd like to show you now is the ROV control room. So when ROV Sebastian is diving, we sit in a dark room filled with screens, watching all the vitals of the robot and seeing exactly what the robot is seeing in real time. Because ROV Sebastian is an ROV, not an HOV, so it's a remote operated vehicle instead of a human operated vehicle. Follow me. So this is where the magic happens. This is where our pilots sit in the front row, and then scientists sit in the back row, pointing out the samples that we want, requesting what we need. And the pilots on the Schmidt Ocean ship are so talented and so patient with us. We make all sorts of hard requests, and they always manage to get the samples that we need. So now you're just seeing some of the pilot controls. It's very dexterous. If you ask them if it's like playing a video game, some of them have the opinion that it is, others don't think it's like playing a video game, so the jury is out on that one, but I think it's like a video game. Now I will show you the main living spaces. So I'm going to take you through some more doors, and you'll get to see where we eat.
This is such an incredible tour. Like, I think that the most of the ship we've ever got to see, the connection's so good. Thank you so much for this journey. This is awesome. Awesome.
I'm glad you're enjoying it, Jesse. So you can see I wasn't lying about the ship being 5 floors tall. There's a lot of stairs in here. So we'll just take a quick look here, but we just have a lot of lounge space and relaxation space. So even though we do a lot of science and a lot of work on the ship, we also get to enjoy ourselves as well when we do have free time. Yeah. Okay. So this is the galley. This is where we eat our breakfast, lunch, and dinner. And that's all that really goes on here. So there's not much else to say about that.
It's nicer than my kitchen at home. I love it.
Okay, that's all.
Fantastic, folks.
Do you have any questions?
Fantastic, folks. Yeah, we have lots of questions together. A bunch have been written in over the course of the last 20 minutes. We had some written in before the broadcast. This has been one of the best tours we've ever gone on, and what a gorgeous ship we've never seen before. We're echoing a little bit, so when I talk and when I share questions, I might put you in the background for a quick second, but I'll bring you in after I've shared all of them. One of the questions we got, which I thought we might get with that skate egg, is what is a skate? A lot of our audience might not know this. Younger kids, so can you share with us?
Yeah, a skate is related to sharks, so it's an elasmobranch, which means that it has cartilage in its skeleton as well. The skeleton is mainly made out of cartilage. If you've ever seen a stingray, it's also very closely related to a stingray, so it looks exactly like that. Just except that these ones are giant Pacific white skates, so they're much bigger. As you saw, the egg was about as big as the receiver that I'm holding, so the skate itself is massive.
Very, very cool. Thank you so much. I wanted to note the egg. I've never seen an egg like that in my life. A lot of our audience might be unfamiliar with the fact that sharks raise. Some of them have live births, some of them lay eggs, but that was like the most monstrous egg in the history of man. So lucky for you guys to have pulled up such a cool specimen. We had a question. You were going around highlighting all these amazing scientists. We got the chance to hear from so many really diverse people. How many scientists are on the ship? How many people are on the ship right now? Can you share with us sort of the retinue, the cast of characters on board the Falkor?
Yeah, so I would say our science team is about 15 people maybe, and then the ship's crew is about 30 people. So we have about 45 people on board the vessel right now.
Very, very cool. You highlighted the tube worm. You brought out this big shell, which I've never seen anyone hold anything like that in my life. That was so beyond cool. Now, you mentioned that that room is really, really cold for keeping specimens good. Is the shell, or the however you want to phrase it, for the tube worm always that hard, or is that because it's in such a cold room?
It's always that hard. It's made out of chitin, so the same way shrimp shells are hard and crabs' carapaces are hard, or crab shells are hard. It's made out of the same material, so it's always very solid. But the tube worm itself, I wish we had some samples to show you. We don't anymore, but the tube worm itself is very soft. So when you take the tube worm out of the chitin sheath, it kind of just flops there, and then the chitin sheath keeps its shape.
Amazing. We had on Lily Simonson, who's been on some Antarctic expeditions. She's been on some deep sea things on the Alvin submersible, highlighted tube worm and the art that she makes the other day. And I love this question because it fits upon something she was talking about a lot too. So her big obsession is Yeti crabs. And we have a student that wants to know, have you seen Yeti crabs? Do you have Yeti crabs? Anything you want to share with us about these really weird creatures would be great.
I wish we had seen Yeti crabs or have Yeti crabs, but we don't. But we have seen other vent crabs down there. I'm not sure what their scientific name is, but they don't look like Yeti crabs. Sometimes they are covered in that white bacterial mat that you get on Yeti crabs as well. So they do look hairy the same way, but they're a different species. We've also seen a lot of squat lobsters. And a lot of different types of tube worms. So we have that giant tube worm where I showed you its big chitin sheath, but there are also smaller types of tube worms that are about an inch thick and grow to a foot or 2 feet long. So those are called no, I'm forgetting the name now, but they're different from the giant tube worms. And we see lots of fish as well. We've seen chaunacops, or those are called little anglerfish. They're also called sea toads. They're pink and they sit on the bottom of the seafloor and look very cute. We've seen zooarcid fish, which are vent fish that exist around hydrothermal vents and look kind of like eels. So we've seen a lot. We also see squids off the side of the boat at nighttime. They like to hang out where the light shines into the sea. So they join us every single night, and a lot of seabirds as well.
How cool is that? What an amazing bunch of diversity you get the chance to witness there. And again, this is one of the things that makes research going vessels so special, is that you find things that you aren't even looking for. You get to just experience the sort of habitat around you when you're out and about. You mentioned the seabirds, which is really, really cool. And then, of course, you get to discover these really wild and amazing creatures, which leads us to our question that we got online. Do you find these hydrothermal vents? Do you find these amazing habitats every time you dive? Is it sort of a lucky guess where they're going to be, or do you have a sense of where they're going to be before you go with the submersible? Tell us more.
We definitely have a sense of where they're going to be because they're the entire focus of our expedition. So the one type of scientists we didn't speak to are our mappers, but nothing happens without them because they use bathymetry and this new technology that we're using that's attached to ROV Sebastian called INSAS to create fine high-scale resolution maps of the seafloor. And then from those maps, we pinpoint where hydrothermal vents are because they exist. They're tall columns on the seafloor, so we can see where there are taller areas and guess that there are hydrothermal vents there. We also have maps that other scientists have created in previous years that we compare to our maps and make decisions on where to go then. But all of this takes a lot of planning in advance. So when we show up to be on the expedition, all of the sites have already been picked, and we do mapping to choose our sites more carefully, but we already know at a base level where we're going to be going.
Very, very cool. I want to stress too that thank you so much to the Falkor team for showing all this footage as we're sort of overlaying this, where you can get a sense of what everything looks like. It's so neat every time we have the chance to feature Schmidt Ocean Institute. So big thanks to the team there. So we go down and we're exploring these things and we have a sense of where we're going. We're using the ROV Sebastian. A question that we get more and more these days when it comes to scientific tools: how much does Sebastian cost? Like, it seems like an expensive undertaking to be out in the ocean and traveling around and getting all this great footage. What's the deal?
Well, I can estimate. The short answer is a lot. Based off of other research vessels I've been on and other ROVs that I've worked with, they range from $2 million to $6 million per robot. So somewhere within that range is what I guess ROV Sebastian costs.
I always like to highlight for our audience too, because these volumes sound like a lot, millions of dollars. Oh, wow, that's so much. The amount of research funding and sort of the money that's put into scientific exploration and discovery, and this is everything from deep sea dives to NASA to going to space to exploring the realms of all over the world, is about 2 to 3% of the budgets of most countries. So we spend way more on many, many other things than we do amazing research and exploration, and it provides us this understanding of the world and universe that we wouldn't ever otherwise have. So I think it's always well worth noting that no matter how outlandish this amount of money seems to cost sometimes, it's actually a really small fraction of what we spend on a lot of other things. So I love when we get this question. Okay, we're sticking with the Sebastian theme. Remote operated vehicle. Can people go into it? We got a question. And do you have anything that people can go in down to the deep depths?
The short answer is no. There's no pressurized chamber, so nobody could go down in or on ROV Sebastian and expect to come back up in the same form. HOVs have pressurized chambers that protect us from the intense and immense pressure that you find in the deep sea. It's crushing. Yeah, that's the short answer. And we don't have anything on the ship currently that we could use to go down as humans ourselves. Sometimes Schmidt Ocean works with Woods Hole Oceanographic Institution, and they have an HOV called HOV Alvin. So sometimes scientists do get to go down in HOV Alvin to the bottom of the seafloor, but on this expedition, we are just using the remote operated submersible.
Yeah, it's worth noting that there are a lot more ROVs than there are human operated vehicles in the world. It's very hard to get people down, and it tends to be a much more expensive expedition to do so. So we've been able to explore a lot more of the seafloor than we'd otherwise ever be able to with purely human operated vehicles. Although I think we all agree that it's very romantic to have the ability to go down as a person down there. Thank you too for the glorious little throwaway line, come back in the same form. I encourage our audience to look up what happens to like a styrofoam cup if you send it to the bottom of the ocean. The pressure is really quite substantial down there. We had a question about you. Is there a favorite field? You got the chance to talk about some of your own samples, some of the scientists you've worked with. Is there something that really gets you up in the morning when you're on board the ship?
A favorite vent field?
No,
or
a favorite
field of science?
scientific field, like a topic you like most.
Oh, hydrothermal vents. The entire focus of this expedition is what I like most. That's what I'm doing my PhD on. It's what I'm devoting my oceanographic studies to for many, many years. So it excites me very much.
Yeah. It's a really special thing because it's an ecosystem that we only discovered in the last few decades. And I know for our young kids, the thought of like 60s and 70s seems like immeasurably far back in the past, but actually it's really, really recent. And the fact that we are exploring this habitat in a new way and finding all sorts of new ones and the amazing life on them, like every day now with ships like, the RV Falkor Too, is gobsmacking. Like it's like the coolest science ever. You can see Moronga now, like we're like just over the moon joyous at the prospect of this. And now we're getting to see some footage of it too. So I'm so glad we got that question. How long are you at sea when you're on the ship? How long are you personally on? Are there people that are on for the entire voyage? What's the deal?
That's a very good question. I am on for the entire voyage, and that's a 31-day voyage. We got on the ship on October 29th. No, not 29th, 21st. The days are all blending together out here. And then we're getting off the vessel November 23rd. So it's about a month-long expedition. And usually when I go on deep sea expeditions, that's how long we go out for, because it takes so much time and energy and planning and funding to get out here. So when we get out here, we do a lot of science and we stay out for a long time.
Very, very cool. You highlighted some of the scientists that were on board with you, but I'm really curious where people are coming from. One of the things I always like to highlight for our kids about science is that it's a really international collaboration. You have people that are coming from so many different fields that get to work together. Can you speak to that a little bit on your experience on the ship?
Yeah, definitely. This is the first ship that I've been on where there have been so many Canadians. Actually, there there are a lot of Canadians. We have University of Victoria, we have Dalhousie University, University of Ottawa, Memorial University in Newfoundland, but we also do have people that have come from the States as well. So you saw the sediment core processing table downstairs, and there are Hope and Maria there that are from the United States Geological Survey. And then even within our Canadian team, we have international students who have come from other places. So Carlos is from Brazil. There's a lot of people coming together in this.
Now, I'm really
Oh,
thrilled that
and
you have
Chong has come all the way from Japan. So
Wow.
sorry to interrupt. Chong has
No,
come all the
no.
way from Japan. So I don't want to forget about that cool tidbit.
That is very, very cool. I mean, it's so nice. And I think to become a scientist, you talked about you doing your PhD. And I mean, actually, I'm going to harp on this for a second and I'm going to segue it. How long have you been doing school? How much longer do you have in your PhD? Like, I'd love to highlight this for our kids leading into something that I want to share.
That is a question you don't ask a PhD student, but I will answer it
I
just for
know.
you.
I'm sorry.
I have been doing it for 3 years, and I'm about halfway through. So in my program, a PhD is usually 5 to 6 years because in oceanographic science, you do a lot of field work. Sometimes that field work gets interrupted and bumped back. There are a lot of dependencies that we have. But the
No.
PhD is normally 4 years. Yeah.
I like to
They
highlight
say.
this, and apologies, thank you for answering for me, but for our kids, because when you're in grade 6, you hear about, okay, you go to grade 12, and then you do 1 degree, and then maybe you do another degree, and then you got a PhD, and it seems like a daunting, crazy amount of school, but it's really important to highlight with someone like you end this and you're incredibly young. You get to work with people all around the world. You get to go on amazing voyages and do exactly what you love for the rest of your life. And so it's not for everyone. You do not need to be a PhD to end up on a ship like the Falkor 2. You can get involved in ocean science or exploration in a wide variety of ways. But if you are passionate about science, don't let that put you off, because it really is an incredible life you get to lead. And as you're doing that school, I know school might seem a little hard now, but when you're doing it, you get to do things like this and enjoy life in a way that a very few people get the opportunity to. So thank you for humoring me. I appreciate that very much.
No problem at all.
We're going to take just a few more questions. Time flies and you're having fun. And this has been like an extensive, wonderful Q&A. So I wanted to ask on behalf of our kids, are there any resources to learn more, whether it's about your voyage in general, something that inspired you to get into ocean science in this way? Like, where can we send kids to get extra excited about the sea?
Yeah, so if you're interested in this specific expedition, it's called the Ultrafine Scale Mapping Expedition. So Schmidt Ocean has a page on our expedition on their website. If you're interested in more about my science specifically and my science communication, I am on Instagram at Imaginative Sci. So that's just the word imaginative, and then SCI. I'm also on my website at moronkeharris.com, so just my full name.com. And those are the resources, the main resources.
Amazing. I've just brought those up, and I'll make sure to send them to all our registered classes. So if you're tuning in, you will get an email with all that to keep the learning going. This has been so much fun. Is there any sort of final message, broad strokes thing that you want to leave our audience with about the work that you do personally, about the work that's going on the ship, something that we can send them home with to sort of keep them extra inspired?
Yeah, one thing I'd like to send them home is the fact that we know more about the surface of the moon than we do about our deep oceans. So ocean exploration, to me and to many others, is a very important field. I think that there's so much down there that's undiscovered and that can benefit our society. And there's also so much down there that, because it's undiscovered, needs to be protected as well. So that's what I would leave you with. And also, if you want to get into this field, just keep trying at it. Make sure that you volunteer in the field. Volunteering can lead to internships, and internships can lead to graduate school programs as well. So don't give up.
Thank you so much for that. There's no better message to leave off on. A huge thanks to the entire Schmidt Ocean Institute, the Falkor team. I'm bringing up all those links on screen for everyone again. This has been beyond a pleasure. Truly, I think the best tour we've ever had on any one of our voyages ever. So a huge thank you to you.
Thank you.
Farewell live, everyone. Have a wonderful day on YouTube and beyond. We'll